Okay, advanced chem students, I'm going to go over your homework with you a little bit, not all of it, but a little bit of it, and then remind you about a quiz that you're going to take today in class. Should be short. It's just over metric conversions, and I believe it's going to be in Schoology. Yeah, it's going to be in Schoology. Let me share my screen and show you. I'm just going to go over chapter 3 homework 5 real fast. There were only 3 problems that you guys were supposed to do. If me not being there is causing you to be like, I'll just wait and he'll just show me how to do it all later, you are running out of time. I'll be back Tuesday, but I think our exam is next Thursday. This is a very short, very fast unit that you must practice. And if I'm not there to check and make sure you're practicing, you need to be doing it on your own. I apologize. That's how it is. You can send me messages if you'd like. I answered 20 something messages, multiple per student, 20 something students today. But you need to let me know and we need to get this done. But I'll be back on Tuesday unless something terrible happens, and we'll see. But I should be there Tuesday, and I'll be there before school and I'll be there after school for a little bit. I know I'm going to be exhausted. I'm already tired. But let's go ahead and get this started and get it over with. So like I said, I'm going to go over those 3 problems real fast and kind of let you see what you'll see on your quiz. But then too, I wanted to work through the last 3 problems of the dimensional analysis worksheet so you can see that kind of working. And that last one, number 8 on worksheet 1 was really actually pretty hard. If you got it, great, you're good. That would be probably pretty close to the most difficult problem you would see on your exam. We're going to throw some more difficult problems at you tomorrow in dimensional analysis worksheet 2. And then the review for the exam is like crazy hard. But we're just trying to show you some of the most difficult stuff. Believe me, I will always practice you guys harder than I test you. You're going to have to do things for me that are more difficult than what it's going to be like on the exam. There should be no surprises on the exam. Okay, so here we go. So looking at this first problem, this was just simply some metric conversions. You're changing milliliters per minute to microliters per second. It is a dual conversion. So you would be changing milliliters. I went too far. Milliliters to microliters. And so a microliter, micro is that mu. So you would be going milliliters to microliters. And then you are changing minutes to seconds. So in the denominator here, you're doing, what are you doing? In the denominator, you're doing minutes, and then in microliters, you would change that to seconds. So you're doing 2 different conversions there. And there's, excuse me, excuse me, there's the setup for it. So chose to do milliliters to milliliters first. We cross out our units. Chose to go milliliters to milliliters first, and then liters to microliters. That's the best way to do it. Don't try to change without going to the base unit. Go to the base unit first. And tomorrow you guys will need to show it like this. You'll need to change from milliliters to liters, and then liters to microliters, and then get your answer. It may be grams to milligrams only, and all you have to do is divide by 1,000, but you need to be able to show how to do it using bars and sticks and stuff. And then the very last one, so you're ending with microliters, but your minutes will cancel with minutes and you're left with seconds in the denominator. And that's how they got to that microliter per second. The one on the bottom, another dual conversion, you've got grams per centimeters squared to milligrams. And so you're changing millimeters squared to centimeters squared. Notice that if you have units that are squared, these numbers, that should be a squared there too, although 1 squared is 1. They're both squared. That is a much missed thing with students, as they forget that if you square both units, you need to square both numbers top and bottom as well. And then the last one is just a kilograms per liter to grams per cubic centimeter. Cubic centimeter is the same as a milliliter. It won't be on your quiz tomorrow, but you need to know this. Know that a milliliter and a cc are the same thing, or a centimeter cubed and a milliliter are the same. So just a density conversion. They're very similar to what we did, or what I showed you in the notes. All right. Here, the average density of the Earth is 5.52 gram per centimeter cube. Change that to kilogram per decimeter cubed. Notice we've got cubed and cubed units. Cubed, 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 cubed. So the numbers that are transferring between the two are also cubed. So you have 100 cubed over 1 cubed and 1 cubed over 10 cubed. Don't miss that. If you look at your your conversions here, our want was to get to decimeters cubed and kilograms. Grams goes to grams. I'm left with kilograms. Centimeter cube, meter cube, decimeter cube there on the bottom. Going to go quickly. And then 95, a little bit different. Excuse me. You would need to know actually that the density of water is 1 gram per centimeter cubed. But the density is mass times volume. So if you're looking for the mass, what you need to know is the volume and the density, and you can go solve for it. Here it is rearranged that I'm boxing. Mass equals density times the volume. And so all you had to do was go find the volume by, multiplying 40 by 20 by 40 times 20 times 30 to find your actual volume in centimeters cubed. And then once you found your mass, it ended up being in grams, but they asked for kilograms. So you had a little quick conversion to do there. I'm not really sure why this says 1,000 grams in the bottom here. It would be better to say 1,000 grams in the bottom here. I think that's a typo. Let's fix the typo. Typo fixed. Okay. Okay, so on dimensional analysis worksheet 1, you guys had the answers already, and I'll post this PowerPoint. So if you want to go slide by slide and look at them, how they're set up again, that's totally fine. But the first one was 240. It was a relatively easy setup. You were just changing from milliliters to centimeters cubed and then centimeters cubed to grams using the density. On the second one, this one gives people fits as far as significant figures are concerned. The setup of it, it's not too bad. They gave you both conversion factors to use, but that right there is 1 sig fig. So the answer needs to be 1 sig fig. There were a lot of people that left too many there. On this next exam, you guys will get the buffer. So if you had 1.1 times 10 to the 8, you still would get it counted correct on your exam. And on a quiz too. Yeah, you guys get buffer for the rest of the year. You're welcome. Excuse me, number 3. A few years ago, cartoon pictured thief running away with some gold dust. It says it has a volume of 8 quarts and it's full of gold whose density is 19.3. What was the mass? And then maybe do a little comment there. It's an 8-quart bucket. So that's your given. That's what you would start with. So put your 8 quarts, change to liters, liters to centimeters cubed. That's kind of a quick conversion there. I don't really like that. It is right. But what we could have done here is had 1 liter on the bottom, change that to milliliters, 1,000 milliliters on top. And then what you would have had is 1 milliliter is 1 centimeter cubed. What they've done here is kind of made it, they skipped a little step and went straight from liters to milliliters, and in their head, they changed milliliters to centimeters cubed. They are totally the same thing, but you could have set these 2 steps in there instead of that 1 step. So you didn't get confused, but it's the same thing. And then the density is at the end, the 19.3 grams per centimeter cube. I hate to say it, but 14,600 grams is 322 pounds. I don't think the thief's going to be able to get very far with that bucket of gold. Anyway, gold's crazy dense. Cost in dollars of the nails. This one I really don't like. Actually, I probably should have done something like, if it says it requires 30 nails per meter, it would have been nice if they had used a decimal place here so that you would know how many significant figures these 30s and 40s had. That would have been helpful. If you had said something like, oh, you need $71, or if you recognize that you only had 1 sig fig in this whole problem, you probably could have said, well, you need $80, and you would be right. It's just kind of set up in a cheesy manner that probably should have been fixed, and that's my bad. Sorry. Unless yours is fixed and I'm looking at the wrong thing here, which is entirely possible. All right. So that was 4. And then you also had the answer for 5. 5 is about light years, which is calculated as a time, but it's actually a distance. And you can use the speed of light to find out what distance light would travel in that amount of time. And then it's given a distance value in terms of, or being called light years. But it's a distance that light travels in 1 year. And you can use the speed of light, 3.0 times 10 to the 8 meters per second, or here 3.0 times 10 to the 10th centimeters per second, to do the conversion and solve. This one, you guys probably did okay on. It's just a little long, but it's kind of straightforward if you use speed to convert from distance to time and then go from seconds to years in your time conversion. Now on number 6, and I'm going to go through and do these start to finish with you. But 6, 7, and 8 are actually more difficult, I believe, than the other ones. So, and it is the wording. A few people have messaged me and said, "Hey, having trouble figuring out what the givens are. Are they giving me all these numbers and I really don't know what's going on?" Sometimes it's a dual conversion where they're giving you something and asking you to convert to something with a top and a bottom that are different. Sometimes they just give you one number that's just one number. Like here, they're telling you that 7 people normally work in the office. So like they're telling you that you have effectively, let me get this working here, 1 office, right? And that's fine. And what you can manipulate that if you want to, like 1 office is 7 people, right? And then 7 people have this volume of whatever. There's a lot of different ways to set this one up, but the easiest way to do it is to just wait till the very end. And if it wants to know how much it is for each person, just divide by the 7 people at the end, that would be kind of easy. So instead, what I'm going to do is take the volume of the office, the 3.25 times 10 to the 4th liters, which is how much it is for the office. That's how much of the volume is there. Now you could divide that right away by the 7 people, like 3.25 times 10 to the 4th liters per every 7 people. That would be totally fine. But I'm just going to do it at the end. So anyway, they tell you that that volume. And then the other thing that they give you is they give you the density of the lead. It tells you up at the top a sample of air, or the density of the lead in air, or lead in gas. Good Lord, listen to me. A sample of air contains that many milligrams of lead per 1 milliliter of that gas. Sorry, there we go. So it's just milligrams per milliliter, but here I have liters, so I can't use that conversion factor. So what I need to do is change liters to milliliters, and then I can use that 1.00 milliliters is 2.33 times 10 to the negative 7 milligrams. And I'm going to write the symbol for lead as lead. Here, the liter is bigger, so it'll get 1, and then the milliliters will get the 1,000. At this point, it says how many micrograms of lead. It doesn't say how many milligrams of lead. The lowercase m is milli, and micro is the mu. So what I need to do is change from milligrams to micros, but I would change from milligrams to grams, and then change grams to micrograms. That's what I would do. So 1 gram is 1,000 milligrams, and then 1 gram is 10 to the 6th micrograms. And at that point, you would have the micrograms of lead. I probably should have continued to write PB as my symbol for the lead. What you end up getting is 7,572.5 micrograms. But what they wanted was the micrograms per person, each person. So divide that total by the 7 people, or 7 persons, let's say, and you end up with 1,080 micrograms per person. So this one was a little weird to read. You could have started with 1 office, and then in 1 office, it's that many liters. You could have said 1 office was 7 people as a conversion factor, and then that many liters is 1 office. It was a little strange. Or you could have just waited till the end like I did and divided by the 7 people. That would be fine too. So here it's done just a little bit differently, but it's the same essentially. They just divided by the 7 people. It's okay. On number 7, it says that you have an ore. It's a mineral mixture that actually contains gold. If the ore has a 3% gold by mass, now that's an important thing to know what that means. If they say it's 3% gold by mass, what they're doing is they're giving you stuff. And this is a conversion factor they're giving you. They're telling you that 3.0 grams of gold is in 100. That's 1,000, Tom. Is in 100 grams of the ore. Yeah, the calaverite. So, and that's fine. but it's weird because people don't ever see this. 3% means 3 over 100. So it's 3 parts gold for every 1 part or 100 parts ore. And so that's how I would write percentages as 3 over 100. In our term, it says by mass, or in this problem, it says by mass. So I would use grams to describe that. But it then goes on to say how much ore would have to be mined to earn $150 million. So what we're going to start with is the amount of money we have, and then find out how much ore we have to have as a result. So my given here is going to be the $1.5 million. Kind of sloppy there. $1.5 million is actually our starting point. They're giving us this conversion factor that I wrote down to kind of show you. And then they're also giving you 2 other conversion factors. I'm going to list them here, but you don't always have to do this. They also tell you that it's $400 for every ounce. And they also tell you that 1 ounce of the ore contains 28.35 grams of gold. And what it says is how much ore would have to be mined. So what you want to end up with is the total amount of ore. So, excuse me, if we end up getting, what did I just do? That's not an ounce of ore for gold. It's 1 ounce is that, 1 ounce of gold. What a moron. 1 ounce of gold is 28.35 grams of gold. Sorry about that. That's just a conversion factor, is that 1 ounce is going to be that amount. So yeah, so what I'm going to end up needing at the very end is the amount of ore, the mass of the ore. This is going to be my last little conversion factor I'm going to use, and I'm actually going to flip it. So what I'll have is 100 grams of ore at the end on top, and then I'm going to work my way over there. So what I have to get before I can use this conversion factor here is I have to get to grams of gold, which means that I'm going to go backwards and use this to change to ounce, change this to dollars, and then I'll get to my dollars at the very beginning. So sometimes you have to look at these and work them backwards, or at least start with the end in mind. So here I'm going to write $1,500,000 like this. I could have written 1.5 times 10 to the 6, but that's fine. That much money, I need to convert my $400, because that's what it is for every 1 ounce of gold. And then 1 ounce of gold is 28.35 grams of gold. And then I can go from my grams of gold, which I have in my percentage, which is 3.0, to 100 grams of ore. And then I'm going to end up getting my mass of the ore. Because they did not ask for a specific unit here, it's not really relevant. I'm going to write the answer 3.5 that you already have, 10 to the 6 grams of ore. That's true, but that's not really tangible to say, whoa, look, it's 3,500,000 grams of ore. That's not really relevant. But maybe if you knew that it was 3,500 kilograms of ore, that might make more sense to you, but it may not either. Either way, it's fine to leave it in that unit since they didn't ask for a specific unit. Yeah, here they've changed it to 3.5 times 10 to the 3rd kilograms of ore, which is fine. 3,500 would have been okay. But yeah, there you go. And then the last one, this one's a lot like that volume problem, although this is a little bit more difficult. The volume problem on the chapter 3 homework 5, where you had to think, length times width times height kind of thing. This is saying a roll of aluminum foil measures this many feet long and this many inches wide. So this is going to be a mess, but I'm going to try to take you through it and show you what's going on. If I were solving this myself, I would do it very quickly, but I'm going to try to just show you here. They're telling you the length, right? So volume is actually length times width times height. They're telling us the length is 200 feet, 200 decimal feet. They're also saying that the width is 12.00 inches. They also give us the mass of the roll is 1.07 kilograms. And it says, what is the thickness of the aluminum foil in millimeters? So the thickness here is the height. If I drew, I guess let's see how this goes, because I'm not going to make another video. But if this is the piece of aluminum foil, let's call this the length and this the width and this the height, the thickness is actually the height. So what I'm solving for in this volume calculation is the height. I am given the length, I'm given the width, and I can solve for the volume by using that density. And so that's what I'm going to do. I'm going to I'm going to go solve for whatever the volume is. So density is mass divided by volume, but I can use dimensional analysis to do this as well. So what I'm given is 1.0. Oh, make sure I've got my notes here. I don't lie to you guys. 1.07 kilograms. And then 1 kilogram is 1,000 grams. And then I can use my density. My 2.70 grams is 1 centimeter cubed. And at this point, what I'll have is the volume. Yeah. Now I'll have the volume in centimeters cubed. I won't have the volume in feet and inches and all that other stuff, but I will have it in centimeters cubed. So if you go do this, you end up getting approximately 396 centimeters cubed. It's really more appropriate to use the entire number here because we're not changing operations. We're not suddenly adding and subtracting versus multiplying and dividing, in which case we would round before we change the rule. But here, I'm just going to write 396 and we'll move on. But I would use the entire number that came out in the calculator to plug in for volume. So what we need to do is we either need to change this to feet or inches or something, or we need to change the other two to centimeters. And I'm going to choose to change the other two to centimeters. So what I'm going to do is take my, my 200 feet. Yeah, and I'm going to change it first to inches. And then I know a conversion of inches to centimeters, which they probably, or I should have given you in the problem. There are 12 inches in a foot. 1 inch is 2.54 centimeters. If this were a test or exam or quiz, we would definitely give it to you. And then you end up getting about 6,096 centimeters. We'll do the same thing for the width. So this is my length right here. Now I'm going to do my width. I already right here have my volume, right, that I already solved for. And I'm solving up top for the height. So I've got my length. I'm going to solve for my width. I've got my volume. I'm just going to plug them into the formula at the top here in a minute. So my width was 12 inches, 12.00 inches. And the same conversion factor, 1 inch is 2.54 centimeters. You end up getting about 30.48 centimeters for the width. I will take these two and plug them in up here. So the length will go in here, the width will go in here, the volume will go in here, and then it's just a regular kind of algebra problem. Let me erase a little down here at the bottom and I'll show you. But I'll show you the work on the other slide as well in a minute. Let me take this away and show you what happens here. So my volume is actually 396 centimeters cubed. My length was 6096, and my width was what was my width again? 30.48. And what I'm solving for is essentially the height or the thickness. And so when you do that, your height ends up being about 2.3 times 10 to the negative 2, or 0.0023. Sorry, I wanted centimeters too. Negative 3 centimeters, so 0.0023 centimeters. They didn't ask for centimeters though, which is really kind of dumb. They asked for millimeters. So I would do a quick conversion off to the side. I'm going to cheat a little and say that 1 centimeter is the same as 10 millimeters and just multiply it by 10, in which case that's going to give you 2.3 times 10 to the negative 2 millimeters. You know, here I told you should go to the base unit and then back out again. I sort of cheated here a little bit, but yeah, you should go centimeter to meter and then meter to millimeter. And it would be 100 on top and 1,000 on bottom, or no, it would be 100 on bottom, 1,000 on top. So the difference would be 10. But anyway, this problem is a little bit more difficult. I would have solved it a little differently in kind of a faster, speedier way, but it wouldn't have worked to show you what's going on in the problem. And this is tough. This is tough, I know. But this would be kind of on the higher order level questioning that we would ask you on your exam. So let me get rid of this. I'll show you the pretty version, although I don't really agree with how they They solved it. They did it as an area instead. They did the volume divided by the length times width down there at the bottom. And they left their length and width as an area and then just solved for the height or the thickness if you like. But the answers are the same. A little bit different way to solve it, but it's fine. So again, I will post this PowerPoint online, and as all the other homeworks are online as well. I've changed the folder structure a little bit. So all you have to do is go into this unit and it says homework and labs and notes. I just couldn't do the day-to-day thing like we had in virtual last year, since none of you really are virtual. I do have a few that are virtual and I'm dealing with that, but for all of you, it's a whole lot easier just to go to the folder and find what you need. So I'll make sure that those homeworks are open and you have access to them. And I will see, this will be the last day apart, hopefully. So I'll see you guys next Tuesday. So ask questions, come see me if you need some help. And that's about it. Yeah. Okay. See you soon, I hope.